Hello friends, welcome. Friends, many of you might have seen this article which says that government to use Prasar Bharati infra to do pilot for direct to mobile technologies in 19 cities. So what is direct to mobile? So what the government is saying is that a consumer will be able to receive signal, TV signal directly into their mobile without using any data connection, right? So they don't require any SIM. Directly the TV signals are going to be received on the mobile, so they can watch various kinds of videos directly on their mobile screens. Now, this is an article which was published on 16 January 2024, and where the Prasar Bharati secretary has been quoted saying that the launch of a pilot is the first step because there are challenges. While this technology is there, it can be adopted, but in a device you require a chip or an attachment. To see that adoption takes place, pilot will be required. This is what he says. Now friends, what I did was I wrote an article just couple of hours back. So this article is titled Direct to Mobile in India, Key Challenges and Way Forward. So whatever challenges the secretary was mentioning, so I have listed down those challenges so that it is transparently available to the readers to understand and read and figure out whether the amount of money that is going to be spent is worth the spend, or it can be spent or modified, the project can be modified to become more useful and effective. So what in this video I plan to take you through those challenges and make you understand in simple terms what are the obstacles that the government of India is going to face as you move forward in this particular path. Now for that friends, I have created certain slides. So I'm going to show you one by one what I basically have listed down in my article. Now typically the network architecture for broadcasting. So what is broadcasting? Broadcasting means the transmission is happening in one single direction and there is no return path. Typically in a mobile transmission, there are two different types of transmission which takes place. It's bidirectional in nature. Let's say if there was a mobile here, the mobile was transmitting back to the base station and the base station has the ability to transmit to the mobile. So there is both paths are possible to be transmitted. Now in case of a conventional broadcast network, you have an antenna, we have a tower on which there is an antenna which is located here. Let's say it is located here, and then the tower is radiating right in an omnidirectional manner, and whatever receivers are available in the area of the coverage area of that particular tower can receive that signal and use the devices to receive TV signals into their equipment for viewing purpose. So that's the whole concept. Now what the Indian government is trying to do is it's trying to create and try a new network architecture which has never been tried anywhere else in the world. Now let me explain what I basically mean. Now everywhere else in the world today, this broadcast network which is based on ATSC technology is being tried and tested for TV reception. It has never been tried and tested for mobile reception, right? And I will explain why it has not been done so, because there are no commercial mobiles available today which can receive ATSC signals and you can view them directly on your mobile. There are dongles which are available, right, for you to buy, but there are no commercial mobiles available with integrated capability to receive those signals. And I'll explain why I am saying so. Conventionally, this is a typical architecture. Look at this slide. This is a typical architecture which is followed in rest of the world. Like US is following this architecture, and there are some other countries also like Korea. They are following the similar architecture. So what is this architecture doing? It has got one high, a tower of a height of 60 to 80 meters where an antenna is located on the top of the tower which is transmitting at a very high power. So there is a huge radius of coverage which is able to cover because of the high power transmission. And now since the device doesn't have to transmit back to the power tower, which typically happens in case of a conventional mobile network, therefore the bottleneck from the point of view of the power of the mobile's capability to transmit back to the transmitter or the tower does not exist. So your coverage can be extended to kilometers, right? Now some hundreds of kilometers. This particular coverage of this particular tower can be as high as 100 kilometers, 200 kilometers, right? So you have a huge area which you can cover, and then in your house, let's say if you look at this diagram, you will find that there is a house on which there is an antenna which is attached on the rooftop of this house, and this tower, the RF signal which is emanating out of this tower is received by the antenna, external antenna, and then you can view this in your TV, right? Because you can have a cable inside and you can stretch it inside your house and you can watch TV using the received RF signal, which we can basically get connected into your TV. So that's the typical network architecture which is being followed rest of the world. Now what we are trying to do is that instead of having a TV, an external antenna, we want a mobile to be stationed here and capture the signal directly from the tower. Now there is a problem here. The problem is that the mobile's antennas are very small compared to what the antennas you will have on the rooftop of your house. They are big, much bigger than the mobile antenna, and bigger antenna will have better gain and therefore it will be capable of receiving the signal from a larger distance. But mobile can't, because their antennas is going to be very small, and especially those mobiles which will have antennas integrated into the device, not those external dongle. Those will be better. Now, even if you have dongles connected to your mobile with antenna protruding out of the mobile, still there is a problem, and I'll explain to you why I'm saying so. Because I was watching this video, the YouTube video, a YouTuber was demonstrating this capability, and I'll run this YouTube video in front of you so that you can have a look at it, what it's saying.
Also record live TV on this app. Although the tuner itself is very sensitive, the range on the included antenna is very limited. I found it works good if you're within 20 miles from the broadcast tower, but understand it's a very small antenna. The signal is going to be marginal if you're anywhere further than that or have obstruction in the way. For example, I'm on the other side of my house. The transmitter is coming from this way, and it's about 15 miles away, and you can see if I move the antenna in a certain spot, it doesn't come in. I have to have it in the exact right spot, at least on this side of the house. But on the main side of the house, I don't have too many issues picking this up, just kind of sitting down and watching it. The slightly
Okay, so you understand what he is talking about. He is saying that it is not possible for him to sit and watch the reception in the mobile because of certain challenges, because of the antenna design and capability and the line of sight reception. But that is not the case when you are receiving signal directly on your TV, when an antenna is located outside your house, means on the rooftop of your house, right? Which I showed you just right in this. So if there is an antenna located, this problem does not exist because this is a static antenna and you are not moving, right? That is why what you need in India is not an architecture like this. You need a hybrid architecture, and this is the architecture which I was talking about. So what you need is, you need a external tower, which is a tower of a higher height of maybe around 60 to 80 meters. Typically the Doordarshans have these kind of towers. And then you require small towers which are typically supporting mobile communication networks, on which you can host your broadcast antennas on the frequency band which you want to transmit. So you will have a mixed network and hybrid network architecture where we have a mix of high power tower and a low power tower working in tandem to support the mobile reception. Because what will happen is, whatever is the challenge that you are going to face from receiving signal from the high power towers can be circumvented by the low power transmitted signal emanating from the low power tower transmitters, and they are going to amplify the signal, and they are going to make sure that the signals that are being received in the mobile is continuous, and you can move along with the device without any difficulty. So that's the architecture you need. So you can't just have one tower in one city, you can have multiple towers. So that's the problem. Now, what is the issue with this network architecture? The problem with the network architecture is the first problem is the following. Now, I'll explain to you what it basically means. It's a little technical, but you will understand what I'm talking about. Now, let's say if you have got two towers, one is a high power tower located, let's say 100 or 200 kilometers away. Another is a low power tower located, let's say nearby to the mobile. Here, mobile is here. You can see the mobile here. And this is a smaller base station. This is the bigger base station, which is a typical Doordarshan tower. Now, what happens is that the mobile is receiving signal from both the towers. Look, one RF link coming here and hitting the mobile, another RF link is coming hitting the mobile. Maybe this is 5 kilometers distance, this is 100 kilometer distance. So what happens is that the frame which is coming from the RF signal, which is coming from the which is emanating out of the Doordarshan, let's say high tower of a higher of a height of, let's say, 60 to 80 meters or 100 meters. So that signal which is coming from 100 kilometers will appear before the mobile at a delay, because that delay is going to be this particular distance which has to travel. It can be 100 meters, 100 kilometers or 200 kilometers. And this 5 kilometers distance, it can travel very, very fast. So what will happen, that the signal, the frames which are going to come and hit the mobile, they are not going to be synchronous. There will be a phase lag, and this is shown here in this diagram. See, you forget about all whatever they mentioned here, just look at these two bars. So the first frame, let's say this particular frame, which is emanating out of this, let's say, the signal number 1. Let's assume that this is signal number 1 and this is signal number 2. The signal number 2 is coming and hitting the mobile with a delay, and this delay is there. Now, in order to ensure that both these signals can be added up together without any confusion and without any interference, you need to reject the signal. This particular block of signal has to be rejected, like whatever you are receiving early, right? That has to be rejected by the mobile, and then the mobile start aggregating the signal after rejecting that particular time slot. So that time slot is called, in simple terms, though cyclic prefix is a more complex than what I have explained, but to explain it in a simple terms, I just have to basically limit myself to this discussion. Otherwise, the discussion will become so long and technical that people will lose the discussion completely. So there will be an efficiency loss because of both the signals are not appearing simultaneously and hitting the mobile. This does not happen in typical mobile network, because mobile networks are not configured in the manner which I am describing here. This is not hybrid network. They are typically like this. You don't have this tower in between. You have these cells separated out by distance, and the antennas are structured or configured in such a way that the signal does not travel beyond the coverage area of that particular antenna. So they do down tilting and prevent the signal from overlapping and going into the area of the other base station, right? So that is where these kind of problems are not there. Significant problems are not there. There are maybe some problem of multipath propagation, and therefore you require cyclic prefix also in case of a typical mobile network, so as to prevent signals getting interference from multipath propagation, where signal can basically collide in a building, side of the wall of a building, and then can hit your mobile by traveling two different paths. So that's why cyclic prefix is required, but the problem is not that significant as what you will encounter in a situation where you have a hybrid structure. So therefore, you will lose efficiency, and then efficiency loss can be as high as 15 to 20%. And it can be more than that in some circumstances if the coverage of the high power tower is going to be very, very significant. So this is one of the challenge that I listed out in this article, right? If you look at this, you can read this article. Okay. So there is a loss of how much? There is a loss of 15 to 20% on efficiency. And the second problem that I have listed down in my article is spectrum utilization versus 5G. What kind of problems that you are going to face from the point of view of amount of channels that you will be able to support. Now, typically, if you look at the IIT Kanpur's paper, this is a paper which was published. They say, in this paper, they have listed down the spectrum band that they are basically targeting. So here, if you find that there will be a spectrum band mentioned which they are basically targeting for the proof of concept. And what is the spectrum band? This spectrum band is this is there in the paper, 526 to 582 megahertz, right? So that's the spectrum band that they're targeting. Now, in that spectrum band, 8 megahertz is the bandwidth of a particular channel. So you will have how many carriers? You will have 7 carriers, right? For between 526 and 582, right? 7 carriers of 8 megahertz of width. Now each carrier of 8 megahertz width can support 13 to 14 SD channel. You can see the calculation here. Therefore, in order to basically drive multiple channels, you have to energize all the 7 carriers, which is from 526 to 582. Because if you don't do it, you will never be able to reach the level of 150 channels, which is supported by DD free dish. So even after energizing 7 carriers of 8 megahertz, you will reach a number of only 120 TV channels only, because you multiply 13 to 14 by into 7, you will reach this number, right? Because that is how the calculation. So 8. So I have basically taken 15 per 8 megahertz carrier rather than 13 to 15. So 15 into 8 will come out to be 120 TV channels. If you don't have that many TV channels, then the network is going to be useless for both the broadcaster as well as for the consumer, because consumer will not have choice. Because consumer will need, suppose let's say there are only 20 channels or 30 channels, it will not be very useful network for the consumer and also for the broadcaster, because it's like a it is like the network effect. If you do not have sufficient number of people participating in the network, why would anybody lock into that network? So you need to have at least 120 channels or more than 120 channels, just like what you have in case of DD free dish. So in order for you to do that, you have to energize all the 56 megahertz of bandwidth which is available here, right? 56 megahertz. Now 56 megahertz is a huge amount of bandwidth, and what kind of problems are you going to face when you energize 56 megahertz of bandwidth is explained in this particular paragraph. So what I am saying is, conventionally, let's take the example of 700 megahertz band. 700 megahertz band, what happens is that it's a 3-sector base station. So every sector is powered to a maximum of 80 watts. So 3 sector is how much? 240 watts. Now, in order to drive 240 watts of power of 10 megahertz in 10 megahertz, you need to have a power capability you have to drive power from the grid. You have to tap power from the grid of at least to the tune of 750 to 1 kilowatt, because that's thumb rule. It's almost like 3 to 4 times you have to drive. Otherwise, you will never be able to drive 240 watts. Now, every kilowatt hour will cost you 10 rupees. That's the price of kilowatt hour. So, for a single base station, to drive a 700 megahertz, 10 megahertz channel for continuously for 24 hours in a day and for 30 days in a month, you will incur an expense of 7,200 rupees for electricity bill. Now, assume that this is typically for 10 megahertz of 700 megahertz band. Now, this 512 to 586 megahertz, 82 megahertz is a near band for 700. So, what I am taking is I am taking 700 megahertz as the benchmark. Now, after having taken 700 megahertz as benchmarks, I am assuming that the 8 megahertz channel is equivalent to 10 megahertz. So, it will be roughly the same. So this number which I have calculated, 7,200 rupees per month, I can multiply that by 5.6 because you need to support 7 channels of 8 megahertz. So that comes out to be roughly around 40,000 rupees per month of electricity expense in order to drive so many channels. Now, in India, how many towers we have throughout the country? We have around 780, roughly around 780k towers, means 7,80,000 towers. So I have basically assumed here 7,50,000 towers. Now, at least, if you are very conservative, right, in order for deployment of mobile TV, you at least have to energize 10% of those towers, right? You can't really go below that. So how many towers you need? You need 75k towers. So 75k towers, if you take that 75k towers and you multiply that 75k towers into the, before that, one more factor is required to be done. 40,000 I have calculated, you have seen that. But this 40,000 will get further escalated by a factor of 1.6 to 1.8 times, because most of the time, you may not have electricity. So you need to drive diesel, you need to recharge your battery. So that will actually, the diesel is actually costing around 4 times the price of the electricity. So there will be, the experienced people on ground tell me that this number has to be multiplied by 1.6 to 1.8 times. So it comes out to be around 72k. Now 72k rupees multiplied by 75k towers into 365 translates to an staggering 1.9 lakh crores of electricity cost. Imagine 1.97 lakh means 2 lakh crores of electricity cost expense. What is the telecom revenue today in the market? If you look at the gross revenue of the mobile operator, it comes out to be around 3.5 lakh crores. Now, if you have to encounter a electricity expense of 2 lakh crores to run 8 channels, right, for mobile TV, and that too 8 carriers of mobile of 8 megahertz to drive 120 channels of TV, does it make any sense? I've been extremely conservative. I'm only taken 10% of the towers, right? So imagine the kind of power cost that you're going to incur. And that will make the business case completely unviable because you will never be able to monetize it. The advertisement cost will be very less, and the number of channels are not sufficient enough to drive the interest of everybody to advertise here. 120 channels are too less, right? And that too SD channels. You're not talking about SD channels here at all. So that's another problem. Then we have the backhaul expenses, because what will happen is that all the base stations will not be connected with optical fiber, so you need to put a satellite dish to receive the satellite signals and then feed it into those low power base station. So you have to basically maintain a infrastructure for supporting the disk, because this disk is going to be roughly around 5 meters or 3 meters radius, right? And then it has to be connected to the base station. So that's another problem. Then we have other issues from the point of view of antenna design. As I already explained, and you can read this, the antenna design is very difficult because when you go into low frequency spectrum of 526 to 582, you will have a wavelength of around 53 centimeters. I have calculated it, which comes out to be 21 inches. Now mobiles are typically, and this 21 inches is the lambda. Now in order to receive signal effectively inside the mobile, you need to have an antenna of the size lambda by 4, which is 5.61 inches. Now imagine, 5.61 inches has to be the size of the mobile phone. And then you have to, on top of it, you have to put 4 antennas in order to have path diversity. So it makes the design of the antenna design of the mobile very, very complex. It's very difficult, and it is not sustainable from the point of view of low cost devices, where the devices are not that big. The smartphones which are bigger is going to cost very, very huge sums of money, right? So that adds another challenge. And then the frames of ATSC3 is not compatible with the 5G frame. So you need to have a separate electronics to basically decode that frame and then process it to basically show it into the device. So you need to add more electronics than what you typically have in case of 5G, because those frames are not aligned with the 5G frame which you see in case of 5G phones. Then there is another problem, is that if the device which is decoding the ATSC signal is not properly integrated into the phone or in form of an ASIC, let's say if it is only DSP, then what will happen is it is going to pull down the overall capability of the device. And you can read this paper here, which I have attached in my note. I'm going to basically put this article in the description, and you can read that, and you will find that it will make the phone very, very the capability of the phone is going to get further hampered because of suboptimal design. So you need to have a tightly integrated design so that everything is properly the chip has to be of proper size. It can't be 28 nanometer. It has to be of the same level, so that there are no interference which is being caused because of the integration of the DSP in the ATSC DSP in the mobile device, right? That has to be taken into consideration. And then there is another issue that we are facing. The patent structure, as far as the ATSC is concerned, is anchored around certain patent pools. And there are certain companies who have not participated in the patent pool. So they are going around, litigating against those companies who are trying to sell the TVs. So LG has already got out of the device manufacturing path of mobile, the TV, ATSC based TVs. Now they have got out. Now you have to read this article here, which in the note, because LG Electronics has made a submission before FCC recently. If you look at this particular document which is attached in my article, you will find that they are saying that they have voluntarily exited this space because of this problem that they are facing, right? They are saying that, look at this article, which says that this is yeah. So so there is a company. If you go here, you'll find that there is a company which is going around. This company's name is Constellation Designs, and they are going around, litigating against the companies who are part of the patent pool and seeking a royalty of 6.75 per device. And LG is saying that it is not worth to basically pay that royalty, and therefore we are getting out of this venture completely. So what it says, LG strongly urges the commission to recognize the role of patents right on both patents, and it says particular commission recognize even though the current voluntary industry standard of RAN commitment appears in general to work well, number of factors including major patent unwillingness to certain number of parties to commit to RAN terms and other threats may undermine the ability of the industry to participate, innovate and develop exciting technology and application and provide ongoing services and features that the consumer desires. This in turn may impact the development of the product and which is relying upon the SCPs. So that is what has happened. LG has got out of this and looks like that this is a fundamental innovation, and this particular company may go after other manufacturers also. So that also has to take into consideration while we go forward with this in this direction. So what I'm basically trying to say, friends, is that there are so many challenges. So one is the loss of spectral efficiency, then the device integration cost, then the power consumption, then there is a battery life issue, and there is lack of ecosystem. There is no mobiles which are available today with the capability of ATSC. The dongles which are going to be outside the mobiles, they will have an issue about integration. They may drain the capacity of the phone. So rather than getting into the path with so many challenges, it is better to look into a path which is globally scalable, where people are already going in the direction. For example, 5G broadcast is a standard which is currently being developed around the world, and it is tested and tried. I am not anybody to say that whether that standard will be successful or not. But if it becomes successful, that becomes an opportunity, because then India can leverage the experience and deployment in other countries where some of the challenges that I mentioned can get overcome. For example, patent issues can get overcome because 3GPP has got a much better patent structure and where it has been tried and tested for such a long period of time. Though there have been a lot of litigation here and there, and people have leveled claims against each other, but that is a much proven and a robust structure compared to what ATSC structure is, because it's in the process of developing, because there are people who are not participating in the patent pool, right? Then we have the economies of scale of devices. There are no commercial devices which are available. Then we have the problem of ATC not being having any kind of synergy with the 5G standard, so therefore they need a separate electronics to decode the signals. That will add further complexity into the device design. So there are so many problems. So my simple and a humble approach, suggestion is that rather than going ahead and deploying in infrastructure and doing a pilot and spending so much of money, why don't we wait for the 5G broadcast technology to become successful, or see and how it progresses in rest of the world, because that will basically align with the ecosystem of devices and infrastructure, and there will be a lot of device manufacturers which will support it, because it will become part of the 3GPP standard. Not only you will have a lot of device manufacturers which will be organically will build that capability into the phone, and that will be seamlessly going to integrate with the 5G capability. The 5G is already the frame structure, and therefore there will be no discontinuity between the broadcast frame as well as the 5G frame, and that will optimize the cost of the device. So I think this is what I basically want to say, friends, and you can look into this article and you can understand it much better, right? And let me know what you think. So my view is that it is basically a waste of money and resources by going ahead and deploying something which has never been deployed anywhere else in the world with so many challenges. So we should not do this. We should wait, or we should use this spectrum for something better. For example, the spectrum cost of low frequencies is huge. They're exorbitantly high. We should reduce the spectrum cost. We should encourage operators like Bharti to basically get more low frequency spectrum for 5G so that they can deploy standalone network. Today, 5G just has only one operator having 10 megahertz or 700 megahertz spectrum. We need more low frequency spectrum for 5G. Rather than going in this path, we should reduce the price of low frequency band and make available 600 megahertz band for the operators to take, so that the 5G network can become more useful and robust and support all these capabilities that we are trying to build through something else, right? And going around and trying to accomplish what we can very easily accomplish using our 5G network with so much amount of investment which has already been made. So friends, thanks for your time. I hope that you have understood what I am talking about. You can read this note and can further let me know if you have any further comments or any queries. I will be happy to answer them. And thanks for your patient listening and watching this video. Thank you very much.